So we have really three categories of exceptions to the octet rule. We have incomplete octets, so we have something like boron, which doesn't actually have an octet, but this is the stable structure for BH3. We also have expanded octets. So if you look at this situation, something like sulfur tetrafluoride, the sulfur has 10 electrons, so it's an expanded octet. We can also have a similar example with AsBr5, so we can have 10 electrons there. So there's a specific situation that must exist in order to have expanded octet, and that is that we must have d orbitals available. So we don't start having expanded octets until we get to the third period on the periodic table, because that's the first time that we have a d orbital available. Alright, so we can take a look at these and just kind of go through how we would figure out what we have. So we have boron, and if you look at boron, boron is in column 13, so it has 3 valence electrons. So I'll do this up here. So boron has 3 electrons, and 3 fluorines have 3 times 7, so that's 21 electrons, and so this one would be like so. Now you may wonder, how do you know that, or how would you be able to figure that out? So there's another concept that I need to introduce you to called formal charge, but I'm not going to do that right at this second. So I would say you should just remember that it's pretty common for boron and aluminum and beryllium to form incomplete octets. So when you look at something like PCl5, it should probably be apparent to you, I think, that that's going to have to be an expanded octet. So we have phosphorus with 5 electrons, and we have chlorine, which has 5 times 7 electrons, so that's 35, and then that's 5, so that's 40 electrons. And so in this case, let me see if I've left myself room, so I'll try to squeeze it in down there. So we have P, and it's going to be surrounded, so phosphorus is going to be surrounded by 5 chlorines, and then each of these chlorines, I'm not going to try to draw them all in, but each of, I'll use a different pen, each of these, actually I'll do this. So each of these chlorines actually has 6 more electrons. And you notice I'm using a little different way to represent those electrons. I'm just drawing a line. So in this kind of notation, that line stands for 2 electrons. And then if you go through the process with SF6, let me just try to show you that one. So SF6, I'm not going to do the whole thing, but let me see if I can, yeah, I'll move this up like that. So SF6 would end up looking like this. So it's gonna, there's going to be a sulfur, and we're going to have 6 fluorines around, and each of those fluorines is going to get 3 more pairs of electrons. All right, so let me do this. So using the same notation that I used before, I can put the rest of those electrons around the fluorine like so, and that will give us all of our electrons. So to summarize, carbon, nitrogen, oxygen, and fluorine will always obey the octet rule. So boron and beryllium frequently have fewer than 8 electrons. Second row elements will never exceed the octet rule because they don't have a d orbital available for bonding, but third row and heavier elements will sometimes follow the octet rule, but in other cases can exceed the octet rule by using those d orbitals. And this is just summarizing sort of how you would go about dealing with the situation with expanded octets, which we'll practice more in class.